Hey guys, it's Mr. Moberg, and this screencast is going to answer the question, what is matter? Throughout it, you're definitely going to want to find a place to take some notes. And if you have any questions at all on anything, please ask your teacher or people nearby. They'd be happy to help you out. So what is matter? Well, number one, it is everything we see around us. The image on the screen shows a whole bunch of examples of matter. And here's a question I kind of like to ask myself when I'm considering if something's matter. Could you touch it? And if so, the answer is it's probably matter. Now, this is true for most matter. Most of it we can touch and most of it we can see, but we cannot see all of it, such as gases like air in the room. Number two, matter must be made of particles. In other words, it must have mass. I'd like to break down this word particles because it's a really important word for this course. We're going to be using it all year long. The word of particles is the word part. It means it's part of something. Now, in the past, you've seen the word atoms, elements, and compounds. You've also looked at the periodic table. And I want us to classify all of those things as particles. Particles make up stuff. They make up everything. They are the smallest parts of those things. One way to think about it is if you were to place anything or matter on a scale, like you see in the bottom left here, if that scale registers something, then it most likely is matter. Here's another image that I think is helpful for the word particle. I want you to think about these small, tiny little parts or specks that are always moving that make up stuff. Number three, matter must take up space. In other words, it must have volume. Now, some things take up more space, like maybe Ken's hair here in the picture, or some things might take up less space, like this cat crawling into the bowl. All things take up space. It's just a matter of how much. We measure volume using these scientific tools in the bottom left-hand corner. We'll explore those in a little bit. And lastly, number four, particles must have energy and be moving. Now, it just happens that particles in a solid state tend to be more compact and tightly spaced, whereas in a liquid and a gas, they tend to get spaced out a little bit more and more. Right now, I'd like you to have a group conversation and discuss the question that you see on the screen. So these dots represent particles. Which of these images has the most mass, the most volume, and which is most likely in a solid state? I'd like you to find someone nearby you and have a brief conversation about this. Now, I do want to point out this image you see here in the top right-hand part of the screen. Anytime you see this image in a screencast going forward, what that means is it's a chance for you to collaborate and talk and work with people around you. So go ahead and pause your screen and discuss the question. Okay, now that you've had a chance to talk about it, let's answer it. Which of these images has the most mass? Well, we've talked about mass being particles. The most particles are located in image D, so this is going to be the most mass. Which has the most volume? We said volume is the amount of space particles take up. All four of these images take up the same amount of space, so they all have the same volume. And which is most likely in a solid state? Well, image D, the particles are closest together, so they are most likely in that solid state. Another opportunity now for a discussion question for you. Again, we see this image. This is kind of a fun one to think about, is what is not matter? It can be kind of tricky because, as we mentioned, pretty much everything you can see around you is matter, so what is not? Pause your screen, see if you can think of it, or even try looking it up. Okay, now that you've had a chance to do that, let me give you the best example of something that is not matter: energy. Energy is the ability to do work. Now, throughout this course, energy is going to be a huge theme that comes up over and over again. We're going to learn this year about light energy, gravitational energy, thermal energy. Now, energy and matter are very interconnected. They're always working and interacting with each other. However, in terms of definition-wise, they're actually different things. So let's recap. Number one, matter is everything we see around us. And sometimes we can't see it, but it takes up space. Matter must have mass and be made of particles. It must have volume or take up space. And those particles are always moving. In other words, they always have energy, and this can determine what state they are in, whether it's a solid, liquid, or gas. I hope this was helpful. Thanks a lot for listening. If you have questions, please feel free to shoot your teacher an email at the email you see on the screen, or talk to people around you. And thanks a lot.